Completed in 1944, the original Kentucky Lock and Dam project has served flood control, power generation, water supply, navigation, and recreational needs on the Tennessee River system for over 50 years. Studies performed by the U.S. Army Corps of Engineers, Nashville District, have identified the existing 600-foot-long Kentucky Lock a major cause of shipping delays, as most tows must use double lockage to pass through the existing structure. In cooperation with the Tennessee Valley Authority, the Corps of Engineers is planning a new 110-foot wide by 1,200-foot long Kentucky Lock addition, located immediately adjacent to the existing lock. The lock addition will significantly improve navigation at the site, increasing shipping efficiency by virtually eliminating delays and greatly reducing shipping costs. Several other features planned for the project will enhance recreational opportunities at the site. Bergman Associates has provided construction phasing, scheduling, and planning services to the Corps of Engineers Nashville District for the Lock Addition project. These services address the overall feasibility of construction plans, provide a clear understanding of potential conflicts, and provide a tool that ensures the efficient completion of this important project. Before the lock construction can be fully completed, several site features must be reconfigured and several major structures relocated. Existing U.S. Highway 62-641 and P&L Railroad alignments that currently reside on Kentucky Dam will be relocated downstream of the lock and dam as new independent structures. The new structure locations will require relocation of the highway and railroad approach alignments on both the west and east banks of the river. 4 electrical transmission towers on the east bank will also be relocated, which will provide the horizontal and vertical clearance necessary to construct the new lock. Major components and steps in the new lock construction include the upstream cofferdam, a cellular structure that ties the existing lock land wall to the east bank, permits excavation and construction of the upstream portion of the lock. The downstream cofferdam, which permits excavation and construction in the downstream lock area, consists of 2 structure types. Float-in concrete caissons are connected to the existing land wall and significantly reduce lock outage time with their efficient installation. A cellular structure ties the float-in segments with the east bank. Protection cells guard the cofferdam from accidental vessel impact. Upstream lock excavation involves removal and stockpiling of approximately 900,000 cubic yards of material. Lock excavation will be staged to permit anchoring the existing lock land wall. Upstream lock construction includes monoliths 1 through 5, landward monoliths 6 through 8, and the upstream miter gate. This work also includes provision of a temporary visitors center and overlook area for public viewing of construction. The partial permanent east bank embankment. This structure provides a second line of protection against Kentucky Lake pool loss. Its construction permits removal of the existing highway and railroad embankment that serve this function through the early stages of construction. Downstream and middle lock area excavation, including excavation of the existing highway and railroad embankment, totaling some 1.1 million cubic yards of material. Downstream lock construction, monoliths 25 through 32, consists of conventional cast-in-place concrete and includes the downstream miter gate. Lock monoliths 6 through 24 will be constructed of cast-in-place concrete and will complete the middle lock construction. The upstream floating approach wall, the downstream landward approach wall, and lock approach dredging. A new lock operations building, lock backfill, utility relocations, and final site development and build-out will complete the new lock work. Recreational components of the project include the bicycle pedestrian bridge that connects the east bank with Kentucky Dam, thereby providing recreational access between Kentucky Dam State Park and the Grand Rivers area. A new boat launching area, enhanced fishing access, and improved fishing facilities. The existing lock will undergo a major rehabilitation once construction of the new lock and associated facilities is complete. To avoid costly interference with the navigation industry's needs, the existing lock must remain operational to the greatest extent possible during the course of the new lock construction. Existing and relocated highway and railroad corridors must also remain open to traffic at all times. These operational constraints play a key role in the phasing of the lock construction. Several other constraints must also be overcome. Site circulation patterns must support both construction activities and access to key facilities for existing lock operation and maintenance personnel. Access and parking for construction employees also need to be accommodated, with as many as 500 construction employees on site during peak construction periods. Excavation stockpiling for the lock will be handled at two facilities, Taylor Park Campground and the Vulcan Disposal Area. Access to these facilities must be maintained with minimal impacts on public highways. Severely sloped terrain in the immediate vicinity of the lock limits available space for construction staging and laydown. Facilities are required for concrete production and formwork and reinforcing fabrication for both conventional and roller compacted concrete. Additional areas are required for long lead materials storage, steel fabrication, construction office trailers, and construction equipment maintenance and parking. Environmental considerations also result in restrictions on work activities. Seasonal restrictions apply to both headwater and tailwater marine activities to protect fish spawning. The site also provides habitat for several endangered species. Workspace limitations and specialized construction procedures are required to ensure their protection. Bergman Associates has developed a broad range of solutions to overcome the constraints associated with the KentuckyLock addition site. Alternative on-site haul and access roads were developed to promote the efficient movement of materials, personnel, and equipment with minimal disruption to the public. This is illustrated through development of an upstream lock excavation and haul road plan that uses the existing lock bridge underpass to permit on-site access for construction equipment. This configuration minimizes impacts to the public while maintaining key facilities and access for existing lock operation and maintenance. A similar approach was used in developing alternative access routes for downstream and middle lock excavation and construction. The Vulcan Disposal Area will receive all downstream and middle lock excavation. Constrained by the TVA transmission towers, the existing highway and railroad embankment, and the severely sloped terrain on the east bank, alternatives were developed to maintain uninterrupted on-site access for concurrent upstream and downstream work. A visitor center and overlook area concept was developed to permit public access for viewing of ongoing construction while maintaining separation from work activities. With lock excavation and construction access routes taking much of the available area adjacent to the new lock, construction staging and laydown areas were evaluated to optimize workspace for the various construction contracts. One of the first areas scheduled to receive dry excavated material is Taylor Park Campground. This will permit development of a relatively large level area suitable for staging and laydown. The lower levels of Taylor Park Campground are reserved for sheet pile storage, cofferdam template fabrication, and related marine activities. TVA Area 5 has also been designated an area for staging and laydown. This area appears to be among the best choices for material fabrication yards, as rail access will permit efficient transfer of materials to the site. In addition, TVA Area 5 was also identified as a preferred location for the conventional concrete batch plant that supplies nearly 500,000 cubic yards of concrete for the lock construction. The lower East Bank tailwater bench area has been configured for bridge construction access, access for the downstream landward approach wall, cofferdam fabrication and related marine activities, and land transfer of dredged materials. Staging and laydown for both the highway and bridge work are generally limited to the West Bank area. This minimizes impacts to the already congested East Bank areas. Because the existing lock must remain operational during the course of construction, access must be maintained for both operations and maintenance personnel. This is accomplished by providing both convenient and alternative access routes, as well as timely relocation of key facilities. During the early stages of construction, lock personnel will access the operations building via the East Bank Connector Road. As upstream lock construction progresses, the core maintenance facility will be relocated and lock access transferred to a newly constructed upstream cofferdam access road. Access will also be maintained at all times to both the existing TVA facility and Powerhouse Island. With an estimated construction cost of $532 million, the KentuckyLock Addition project represents a major financial commitment to improve shipping on the Tennessee River system. Bergman Associates developed work quantities, production rates, construction durations, and schedules for each major component of the KentuckyLock Addition. An extensive evaluation was made regarding construction methods and processes, where timelines were developed to account for activity relationships, environmental and workspace constraints, and project resources. The comprehensive but flexible schedule was configured to permit optimization of design and construction based on both the logistical progression of work and available funding. In addition, spending spread relationships were developed, along with peak employment estimates for each year of construction. The schedule created for this project will serve as both a planning tool and a monitoring tool throughout the course of design and construction. The schedule, coupled with the construction-based techniques developed to mitigate conflicts, permits optimal use of available resources and ensures timely and efficient completion of this important project. In cooperation with the Tennessee Valley Authority, the Corps of Engineers is undertaking the design and construction of KentuckyLock Addition. This project will significantly improve navigation on the Tennessee River system, increasing shipping efficiencies by reducing delays and costs. Additional benefits of the project will be realized in the form of employment opportunities, economic development, and improved recreational facilities for those who work and live in western Kentucky and the surrounding areas. Operational and access requirements, project complexities, environmental considerations, simultaneous construction contracts, and site limitations could all serve as constraints to the construction of this project. Through careful evaluation of these issues in relation to the design and construction process, Bergman Associates has worked with the Corps of Engineers to develop a comprehensive and integrated plan to change these constraints into opportunities. In all respects, KentuckyLock Addition has been planned for success.